Today we're going to graph polar equations by converting them first into rectangular equations and then plotting them on a polar plane. It's important to remember the different equations we have in our toolbox to convert between polar and rectangular. So when I look at r equals 4 and I'm trying to convert it into rectangular coordinates, I compare what I have with the different tools in my toolbox. This only has an r. There's no sine or cosine or theta. So I'm going to try to get it to look like this, r squared. There's two ways to change r into r squared. I could square both sides, or I could multiply both sides by r. If you multiply both sides by r, you end up with r squared, which is great because that's x squared plus y squared. But on this side, you have 4r, which doesn't really go with any of these. So instead of multiplying both sides by r, I'm going to square both sides of the equation. I can do anything I want to the equation as long as I'm doing the same thing on both sides. Now I have r squared equals 16. I can replace r squared with x squared plus y squared because r squared is equal to x squared plus y squared. And now I recognize this as a circle with center at 0, 0, because there's no h or k here, and radius equal to 4. So here's the center of my circle. Radius is 4, 1, 2, 3, 4. So when I graph this, I just trace this fourth circle from the center. Now, hopefully you notice we got back to the exact same thing we started with. So there are connections between our polar form and our rectangular form. Next one, theta equals 5 pi over 6. We're going to convert this to rectangular form with an x and a y. So I compare what I have in polar form with the different tools in my toolbox. And I can use this last equation here. Theta equals inverse tangent of y over x. So if I replace theta with inverse tangent of y over x, that's equal to 5 pi over 6, then I can rewrite this using inverses as y over x is equal to the tangent of 5 pi over 6. Now I have an equation in terms of y and x. I'm going to keep going. The tangent of 5 pi over 6 is root 3 over 3. So y over x equals root 3 over 3. And we're used to seeing our equations in terms of y equals, because I don't have any squared terms here. I know it's not a circle. I'm going to multiply both sides by x so that I can solve for y. And now I have y equals root 3 over 3 times x. This is a linear equation. It's in slope-intercept form. Y equals mx plus b. The y-intercept is 0. The slope is a positive root 3 over 3. Now, when you go to count rise over run, counting root 3 over 3 is a little strange, but I can use the fact that this is supposed to be negative, excuse me. This is going through the angle 5 pi over 6. So this slope, negative root 3 over 3, will actually just take me through this line right here. The reason we're converting from polar form to rectangular form is so we can make connections between the rectangular graphs that we're familiar with and our new polar graphs. Next one, r equals 2 times cosecant of theta. Well, first of all, I don't have cosecant anywhere in here in my list of tools. So what I'm going to do is use the fact that cosecant is the reciprocal of sine and rewrite this as r equals 2 over sine theta. Now I'm getting closer to one of these. None of these have a denominator with sine. So the next thing I'm going to do is multiply both sides by sine of theta so that I can get it out of the denominator. When I do that, I end up with r times sine of theta is equal to 2. Now, when I go to my toolbox, r times sine of theta is equal to y. So I can substitute y in place of r sine theta. And now I have the equation y equals 2, which I recognize as a horizontal line through 2. So I go to my graph, I go up to 2, and I draw a horizontal line. Next equation. R cosine theta equals -3. When I look at my toolbox, I notice that r cosine theta is equal to x. So right away, I can substitute x in place of r cosine theta, and now I have x equals -3. I recognize this as a vertical line that goes through -3. So when I graph it, I go to -3, and I draw a vertical line. Next equation. R squared equals 4 sine theta. I compare what I have here with my toolbox, and I notice r squared can be replaced with x squared plus y squared. On the right-hand side of the equation, r sine theta can be replaced with y. I recognize this as a circle because I have x squared and y squared. However, I have it equal to 4y. So what I need to do next is rearrange my equation. I'm going to subtract 4y over. And I'm going to complete the square. So that I can get this into the x minus h squared plus y minus k squared equals r squared form of a circle. Then I can see the center of the circle and the radius, and I'll be ready to graph. When you complete the square, you take half of the b value, so half of 4 is 2, and then you square it. 2 squared is 4. So to complete the square, you do b divided by 2, and then you square it. Whatever you add to one side of the equation, remember to add to the other side of the equation. X squared just stays x squared. Now I can factor y squared minus 4y plus 4 into y minus 2 quantity squared. And 0 plus 4 is 4. I have a circle here in standard form. The center is 0, 2, and the radius is 2. When I graph this, I go to 0, 2, and then I draw a circle with a radius of 2. So I'll come up 2 and down 2, and then try to draw a neat circle. Last example. R equals -2 cosine theta. When I compare this to the previous example, I notice that instead of r squared, all I have is r. Instead of r sine theta, I only have cosine theta. So if I multiply both sides by r, then I can have a similar situation to what I had before. R squared, which, using my toolbox, can be replaced with x squared plus y squared. And on the right-hand side, I'll have r times cosine theta, which can be replaced with x. Again, I have a circle. I'm going to add 2x to both sides and get ready to complete the square so that I can have my equation in standard form and find the center and the radius of the circle. Remember, to complete the square, you take half of the b value, which is 1, square that, and you get 1. Whatever you add to one side, remember to add to the other side. Now I can factor x squared plus 2x plus 1, x plus 1 quantity squared. Still have y squared. 0 plus 1 is 1. Now I can see that the center of the circle is -1, 0 from h and k, and the radius is 1. And I'm ready to graph. The center, -1, 0, radius 1. Draw a nice, neat circle. The reason we're converting from polar to rectangular form is so that we can start to recognize the connection between polar form and polar graphs and rectangular form and graphs on the rectangular plane.